talking about direct variation, well, direct, inverse, and joint variation today. Direct variation is any scenario where these few things happen. An increase in x results in a proportional increase in y, or a decrease in x yields a decrease in y. The key is it's proportional, always having the same kind of rate of change or slope to it. Secondly, an x value of 0 yields a y value of 0. This is the same as saying it passes through the point 0, 0. So if ever x is nothing, y is also nothing. It is possible to go through the point 0, undefined. That actually happens in inverse variation, which we'll talk about later. Sometimes an x value of 0 just yields something that makes no sense, and that's undefined. And they can always be expressed in the form y equals kx. You'll note that this is actually a linear form. It's really like y equals mx plus b, but the b value is 0. We call it k. It's just kind of this value you have to work with and play with, and you'll see how we use it in a second. It's essentially saying whenever you have direct variation, you have a proportional relationship where things increase or decrease together, and the proportionality is what's key. So here's an example. Momentum of a remote-controlled car varies directly as its speed. If the momentum of the car is 660 newtons when the speed is 30 miles per hour, find the momentum if the speed is 40 miles per hour. There's a lot of information here to kind of sift through, and you could probably reason through it without following this formula. I mean, y equals kx is whenever you see varies directly, you've got y equals kx. So you have to think what's x and what's y. Well, the momentum depends on the speed. So momentum is y, and speed is x. So I'm going to say 660 equals k times 30. And I solve this for k, so I divide both sides by 30. And 660 divided by 30 is 22. So you get that k equals 22. Now this number k always means something, like it's some important part of the scenario that's happening. In this case, you might remember that momentum is actually mass times velocity. And we found momentum and we found velocity. So this is actually the mass. This car weighs 22 pounds or 22 ounces. We don't need to find the newtons. I guess newtons are pounds, yeah. It weighs 22 pounds. That's the mass of the car. Well, now we have to answer this question. Find the momentum if the speed is 40 miles per hour. We can again go with y equals k times x. And now we actually know what k is. K will be 22 from this moment on. Every time we do it, it's 22. And the speed has gone from 30 to 40. We're trying to find the momentum. We do 22 times 40, which is 880. An increase in x going from 30 to 40 led to an increase in y from 660 to 880. That's direct variation. Had the car been traveling at 0 miles per hour, obviously the momentum would have been 0. That's the point 0, 0. All direct variation problems come in the form y equals kx, and k is called the constant of variation. Just like we talked about in that last problem, momentum is really calculated as newtons times mass. Newtons equal mass times velocity. Newtons equal m times v. So it's like n equals mv is the same as y equals kx. And you just define y to be your newtons and x to be your velocity. The number b of Blangos varies directly as the amount z of Zingras, and b equals 18.4 when z equals 33. Find z when b is 30. I picked two words that I made up and made no sense, because often when you do word problems like this, that's how it feels. It feels like you see all these words and all these things that just don't mean anything to you and don't make any sense, and everything has its own odd unit. But since I know it varies directly, I know I'm doing y equals kx. And since y varies directly as x, this I'm going to call my y variable, and this I'm going to call my x variable. And it pretty much always sets up in that form where you say y varies as x, so whatever comes first is y, whatever comes after it is x. So now I'm going to say here's a y value and here's an x value. 18.4 equals k times 33. And I solve both of these, solve this for k. 18.4 divided by 33 is... Oh, where'd it go? It's just gone. .4 divided by 33. 0.5575. So now find z when b is 30. This is my y equals kx form again, but now I know what k is, and I know what y is, and I solve. I recommend you leave that decimal stored in your calculator. So don't type in 0.5575, but do 30 divided by the previous answer. The second negative gives you your previous answer, and you get 53.8. So if b is 30, z was 53.8, you'll notice the b values got bigger, and the z values got bigger. So an increase in one led to an increase in the other. Joint variation is variation with more than two variables. It's basically doing variation a couple times, but you can still write it down in one equation. For a really basic example, the area of a triangle varies jointly as its height and its base. So the area depends on both the height and the base. It can be written as a equals k times bh. If you want to do your y equals kx form, it'd actually be z equals kxy. But I know moving that y around causes people some problems. So we can just do that area equals base times height times some constant k. So if the area of a triangle is 20, and the height is 10, and the base is 4, height is 10, base is 4, I solve to find k. And now you realize, well, yeah, duh, we knew the area of a triangle was y equals 1/2 base times height. Really, area, A equals 1/2 times base times height. But this is kind of just to show what that k value really stands for. It stands for some constant that's just always present in your formula. In this case, it's the 1/2, because the base times the height times a half gives you your area. So now it says, find the base of a triangle if the area is 60 and the height is 14. So we have A equals kbh. The area was 60. We know the k value is a half. The base we don't know, but the height was 14. I'll do 60. Well, 1/2 times 14 is 7. 60 divided by 7. 8.6. Base is about equals 8.6. So there's joint variation. It's just got multiple variables in it. Don't let that throw you off. You're still doing the same thing. There's just going to be a few things taking place. Finally is indirect variation. Indirect variation is when an increase in x results in a decrease in y, or vice versa. So if one thing goes up, the other thing goes down. This is where you don't actually contain the point 0, 0. You have the point 0 undefined, because it's set up like y equals kx. K over x, excuse me. So if x is 0, you have y equals k over 0, and that's undefined. The amount of time it takes to set up for a dance varies inversely as the number of people there are helping. So the more people you have helping, the less time it takes. As the number of people increases, the time required decreases. If it takes 2 people 12 hours to set up the dance, how long would it take 7 people? We can set up as y equals k over x. Time is y, and people is x. So we'll do, it takes 12 hours for 2 people, which means that my k value is 24. Multiply both sides by 2. My k value is 24. So now how long would it take with 7 people? Well, the question is, how long would it take? So y is staying y. We don't know how the time is. How long would it take 7 people? And 24 over 7 little over 3. I should do it as a fraction, but I won't. Let's make that a fraction. Obviously, it's going to be 24/7, yeah. 3.4 hours. So it takes 3.4 hours. It makes sense that if you had no people, the job would never get done. So if x is 0, y is undefined because the job actually never gets finished. Okay, one thing to make clear, a variation relationship, there can't be any addition or subtraction. Addition or subtraction ruins proportionality. Here's what I mean by that. 2/3 and 4/6 are proportional because they reduce to the same thing. But if I took 2/3 and added 1 to the top and bottom, I get 3/4, and 3/4 is not the same as 2/3. So any addition or subtraction tends to kill proportionality. So if ever you have a plus or minus somewhere in your equation or in your reasoning, you've lost the variation relationship. An example is there are 10 cookies and you and your brother are going to eat all of them. A lot of people think this is a direct variation because if I eat, the more cookies I eat, the less my brother eats. If I eat 8, he eats 2. If I eat 9, he eats 1. The more I have, the less he has. But that's not inverse variation because this actually sets up like this. If x equals the number of my cookies and y is the number of his cookies, the equation is x plus y equals 10. There's no multiplication happening, it's all addition. And this doesn't pass through the point 0, 0, because if I have 0 cookies, he has to have 10 cookies, which obviously would never happen because who's giving him cookies? Any sort of addition or subtraction can't be a direct variation or inverse variation relationship because addition and subtraction doesn't have proportionality and wouldn't contain the point 0, 0. So to recap, direct, joint, and indirect variation are all proportional relationships that contain the point 0, 0 or 0 undefined in the case of indirect variation. The value of k is called the constant of variation and is often the first thing that needs to be found in the equation y equals kx.